Powers of 10. Power terms are exponent terms with two parts, a base part and an exponent part. In this section, we will study the rules for working with powers of base 10, such as multiplying powers of 10, dividing powers of 10, and raising a power of 10 to a power. Note, these rules may also be applied in power terms with bases other than 10. Multiplying powers of 10. Think of the rule as a shortcut for simplifying a product of exponent factors. The long way of multiplying powers of 10 is to write out all of the factors and count the number of factors. For example, multiplying these two power of 10s, the long way would be to write out all the factors of 10 to the third and all the factors of 10 to the fifth, multiply them together to get 10 to the 8th. If we write out all the factors of 10 and count the number of factors of 10, we can see that there are 8 factors of 10 in all. This seems easy enough, but can become very tedious for large exponents. For instance, if we were multiplying a power of 10 with exponent 35 by a power of 10 with an exponent of 50, we would not want it to be necessary to write out all the factors of each and count so many factors. Therefore, it is more efficient to use the following general rule when multiplying powers of 10. When multiplying powers of 10, add the exponents. Example 1. So here we want to multiply these powers of 10. We have power of 10 to the negative 3 times power of 10 to the 5th. Instead of writing out all the factors, we'll just add the two exponents, negative 3 and 5, and simplify to get 2. So the answer would be 10 to the 2nd power, because negative 3 plus 5 is 2. Much simpler than writing out all the factors. Dividing powers of 10. Just as we did when multiplying powers of 10, we can also divide powers of 10 by counting the factors. So if we want to divide 10 to the 5th power by 10 to the 3rd, we could write out 5 factors of 10 in the numerator divided by 3 factors of 10 in the denominator, cancel all the common factors, and get 10 to the 2nd. However, this process can also become very tedious for large exponents. Therefore, we use a general rule to help simplify the process. Dividing. When dividing two powers of 10, subtract the exponents. So dividing 10 to the 5th by 10 to the negative 3, if we subtract the exponents, we'll have 5 minus negative 3, which becomes 5 plus 3, which is then 8. So instead of having to write all the factors out and cancel common factors, we can just do a simple subtraction to get the answer as 10 to the 8th. Much simpler. Power of 10 to a power. Here is the tedious counting method for raising a power of 10 to a power, writing out all the factors. So if it's 10 to the 5th squared, we'd have to write out 5 factors of 10 2 times, and then count all those factors to see that the answer is 10 to the 10th. Imagine if we wanted to do 10 to the 50th to the 50th power. It would be an insane amount of factors to have to write out. Here is a more efficient general rule for raising a power of 10 to a power. Power to a power. When raising a power of 10 to a power, multiply the exponents. That's so much easier. So here's an example. 10 to the 5th, the 2nd power. Rather than having to write out so many factors of 10, we can just multiply 5 times 2, the exponent by the power, and get 10 to the 10. Notice the answers are the same, but this was so much simpler. Other power of 10 rules. There's also the 0 power rule that says if you have 10 to the 0 power, it's equal to 1. A negative power rule, if you have 10 to a negative power, it's the same as 1 over 10 to the positive power. And also 10 to the positive power is the same as 1 over 10 to the negative power. Example 4. Simplify and express the answer using a positive exponent. 10 to the negative 5th squared is 10 to the negative 5th times 2. Remember, we multiplied the exponents when raising a power to a power, which is then negative 5 times 2 is then negative 10. So we have 10 to the negative 10, and we can make it positive with the negative power rule by writing as 1 over 10 to the positive 10. Right? 10 to the negative power is equal to 1 over 10 to that positive power. So 10 to the negative 10 is equal to 1 over 10 to the positive 10. Pretty cool, huh? Putting all these rules together, we can do a problem that involves more than one. Example 5. Simplify and express the answer using a positive exponent. First, look at this thing. This is kind of might be a little overwhelming, but let's just break it down. Let's use order of operations, starting inside the parentheses here. Simplify within the parentheses first. We will start with the numerator here and multiply 10 to the third by 10 to the fifth, applying the product rule for powers of 10. We add these exponents. So we get 10 to the 3 plus 5, which simplifies to 10 to the 8th. And now we'll simplify further in the parentheses by dividing 10 to the 8th by 10 to the negative 2. And we might remember that when we're dividing powers of 10, we do what? We subtract the exponents. So we have 8 minus negative 2, which simplifies to 8 plus 2, which 8 plus 2 is just 10. So then we have 10 to the 10 to the negative 4. Oh, this is getting much simpler. Now we have a power of 10 to a power. So the rule was if we have a power raised to a power, we do what? We multiply the exponents. So then we have 10 times negative 4, which is just negative 40. So we get 10 to the negative 40. Oh, a negative exponent. Well, there's a rule we can apply here, a negative power rule that says 10 to the negative 40 is equivalent to 1 over 10 to the positive 40. So ultimately the answer for that ugly expression is just 1 over 10 to the 40. It simplifies to 1 over 10 to the 40.